As the name itself indicates, atomic mass is nothing but mass of one atom of an element. For example, mass of one atom of hydrogen is 1.6736 into 10 to the power of minus 24 grams. Mass of one atom of oxygen is 26.565 into 10 to the power of minus 24 grams. We can observe here mass of one atom of an element is so small, and writing 10 to the power of minus 24 all the time to express their mass is really a cumbersome job. To avoid this, and for the convenience sake, a relative scale of atomic mass was introduced, and that was called as relative atomic mass or atomic weight. Relative atomic mass is abbreviated as RAM. In this system, atomic mass of one atom is expressed in terms of mass of another atom. This another atom is called as standard. Previously, hydrogen was used as a standard. After 1961, carbon-12 isotope is used as a standard. In RAM, that is relative atomic mass, it was assigned that mass of one atom of carbon-12 is equal to 12 AMU or 12U. AMU means atomic mass unit, U means unified mass. Both of them are same. AMU was the old usage and unified mass is the new usage. If we just rearrange this equation and push number 12 to other side, then equation takes the form mass of one atom of carbon-12 divided by 12 equal to 1 AMU or 1 U. In a proper manner, we can write 1 AMU equal to 1 by 12 the mass of one atom of carbon-12. This was found out to be 1.6603 into 10 to the power of minus 24 grams. I want you to keep in mind that AMU is just a new unit introduced just for the convenience sake. Having the definition of 1 AMU as 1 by 12 the mass of one atom of carbon-12, and that is equal to 1.6603 into 10 to the power of minus 24 grams. Now we should be capable of writing relative atomic mass of any element X in AMU, and this is given by mass of one atom of X divided by 1 AMU. If we substitute the definition of 1 AMU in this equation, it takes the form mass of one atom of X divided by 1 by 12 the mass of one atom of carbon-12. This ratio gives us the relative atomic mass or atomic weight of any element X in AMU. Let us consider the example of hydrogen and oxygen. We know that mass of one atom of hydrogen is 1.6736 into 10 to the power of minus 24 grams, and that of oxygen is 26.565 into 10 to the power of minus 24 grams. If we have to express the mass of one atom of hydrogen and that of one atom of oxygen in AMU, then we have to divide these numbers by 1.6603 into 10 to the power of minus 24 grams. After doing that, we get the atomic weight of hydrogen as 1.008 AMU, and for all the practical purpose, we approximate it and consider it as 1 AMU. And that of oxygen is 15.999 AMU, and for all the practical purpose, we approximate it and consider it as 16 AMU. Now if we compare mass of one atom of hydrogen in grams and mass of one atom of hydrogen in AMU, we can see that expressing mass of one atom of element in AMU is much simpler than expressing it in grams. Coming to the definition, relative atomic mass of an element is the number of times one atom of an element is heavier than 1 by 12 the mass of one atom of carbon-12. Observe the atomic weight of hydrogen and oxygen. They are not whole numbers. Why? Because these elements have isotopes. What are isotopes? Let us quickly recall. If we consider an element X, then A indicates the mass number, that is, number of protons plus number of neutrons. Z indicates the atomic number, that is, number of protons inside the nucleus. Isotopes are atoms of an element with the same Z and different A. Example, if we consider chlorine, majorly there are two isotopes of chlorine, that is chlorine 35 and chlorine 37. In both of these isotopes, we have 17 protons, that is Z is same. Coming to the number of neutrons, 35 minus 17, we have 18 neutrons in chlorine 35 and we have 20 neutrons in chlorine 37, meaning chlorine 35 and chlorine 37 are having same Z and different A. In the same manner, bromine is having two isotopes, bromine 79 and bromine 81. Both of them are having same number of protons, that is 35, but bromine 79 is having 44 neutrons and bromine 81 is having 46 neutrons in it. Relative atomic mass or atomic weight of chlorine is 35.5 AMU. We know now that chlorine is having majorly two isotopes, chlorine 35 and chlorine 37. If we observe the relative abundance of these two isotopes in the nature, then chlorine 35 is present up to 75% and chlorine 37 is present up to 25%. What it means is, if we pick 100 chlorine atoms, then in that 75 chlorine atoms are chlorine 35 and remaining 25 chlorine atoms are chlorine 37. Same information about the relative abundance of chlorine 35 and chlorine 37 can be given using the ratio, that is, chlorine 35 is to chlorine 37 is 3 is to 1. What it means is, if we pick 4 chlorine atoms, 3 of them are chlorine 35 and 1 will be chlorine 37. Now, by using this relative abundance, we can calculate the relative atomic mass as follows. Chlorine 35 is present up to 75%, so 35 multiplied by 75 plus chlorine 37 is present up to 25%, so 37 multiplied by 25 divided by total percentage, that is 100. This will give us the relative atomic mass, that is 35.5 AMU. Same relative atomic mass can be obtained even by using the ratio as follows. Chlorine 35 multiplied by 3, that is this, plus chlorine 37 multiplied by 1, that is this, divided by the total number, that is 3 plus 1. This also will give us the same atomic weight, that is 35.5 AMU. This atomic weight calculated based on the average of two isotopes considering their abundance is called as average atomic weight. Relative molecular mass or molecular weight. Abbreviation for this is RMM. Relative molecular mass is the number of times one molecule of a substance is heavier than 1 by 12th the mass of one atom of carbon-12. Relative molecular mass can be calculated just by summing up the relative atomic mass of constituent atoms. Example, we know that relative atomic mass of hydrogen is 1 AMU approximately, sulfur is 32 AMU, oxygen is 16 AMU. If we consider the molecule sulfuric acid, then in that we have 2 hydrogen atoms, 1 sulfur atom and 4 oxygen atoms. If we sum up the relative atomic masses of constituent atoms, then there are 2 hydrogen atoms, so 2 into 1, that will give us 2 AMU. There is 1 sulfur atom, 1 into 32, 32 AMU. There are 4 oxygen atoms, 4 into 16, 64 AMU. Relative molecular mass of sulfuric acid will be 2 plus 32 plus 64, that will be 98 AMU.